Okay, so in the last video we just saw that the state was untangled using PPT, but now I want us to go through the dual and see with the dual how we can find the optimal point. So if you remember, the dual is just three conditions. Um, so the dual of row AB is equal to the minus of W, the trace of W row AB, such that the trace of W is equal to 1, and W transpose trace over A is semi-positive definite. So basically we need to respect those three conditions, and we know also that this minimum is equal to minus sinus 2 theta over 2. So yeah, basically for simplifying the calculus, we can just take the maximally in untangled state. We know it was between 0 and p over 4, so we just take p over 4, which just gives us the state psi plus, because we have cos of p over 4 is equal to sinus p over 4, which is equal to 1 over sin of 2 is 1 square of 2, and that psi plus is just 0 plus 1 over sin of 2, so yeah. So we are trying to search lambda, and lambda is just so minus sinus 2p over 4, so 2p over 4 is just p over 2 divided by 2, and so p over 3 is just 1, 2 just minus 1 over 2. So we just know that the trace of W over AB at lambda star is equal to this, which is equal to minus 1 over 2. And to know the structure of W star, we know that states row AB have coefficients that are null uniquely at the 4 points of the matrix, and on the elements linked to 0, 0, and 1, 1. And to activate these coefficients during the calculation of the trace, having a negative value, we know that W star should have the same structure but inverse, so we need to have this symmetric matrix where we have things on the diagonal and things on the stuff here. And after, we just need to resolve the system. So basically we know that the trace should be equal to 1, so the trace is just diagonal elements, and it should be equal to 1, so because of our condition of our dual, as we write here, here, and so yeah, the transpose trace is semi-positive definite, so we respected the first condition like it should be this. So it means that diagonal coefficients that are not diagonals, such as B, go into the center, because you take the sub-matrices here and here, and you apply positive partial transpose, on both of them, and so B will go here and B will go here. So it just gives us like W star, transpose partial trace, partial transpose, just like this. And so for having this matrix, it is also semi-positive definite, because we need this condition and this condition. We just note that all blocks are semi-positive definite. The diagonal elements isolated should be positive or not, so A should be superior to 0 and E should be superior to 0. And the central block CBBD should be positive too, and so it's equivalent to how like the determinants to be positive. So CD minus B squared superior to 0, AD minus BC if you prefer. The exact formula, and so BO carry B squared is inferior to CD. In order to have the minimal value, we need to develop the calculation of the trace with our state rho AB with the coefficient P over 4. So we just calculate it, and so the trace of the star AB is just equal to 1 over 2 multiplied by A plus E plus 2B, because we just proved that we have the resistor TA like being semi-positive, and now what we just want to do is like write B just 1 to me 0 0 1 over 2 0 0 1 over 2 1 over 2 0 0 0 0. On the one line is only zeros, so and you have your W star, and if you multiply it, like you'll have to be, because like W star is like, as we see before, A B B E C D and the diagonals, and so you'll have like 1 to me of B on the B of B, because it's a trace, you can do the calculation. And so because of this, we just get this is just equal to 1 over 2, minus 1 over 2, because that's our lambda prime. And so you just say that A plus 2 plus 2B is equal to 1 minus 1, because you can just multiply by 2 on the two sides. And so to choose the optimal value, we know that A is superior to 0, E is superior to 0, so the more direct stuff is just to put A equals 0, E equals 0, and B is equal to minus 1 over 2. And if we return to the trace condition, which is A plus C plus D plus E is equal to 1, we then have 0 plus C plus D plus 0 is equal to 1, and so C plus D is equal to 1. And so we have like C equal to, so symmetric stuff is like C equal to 1 equal D. And because we know that our constraints block was like CD is superior to B squared, so B is equal at 1 over minus 2, and so B squared is equal to 1 over 4, and so we search C and D such that CD is superior to 1 over 4, and so superior equal to 1 over 4, and so yeah, symmetric matrix is just 1 over 2 for C and D. And if we replace this in the matrix, we then have like A equals 0, A equals 0, B equal 1 minus over 2, C equal 1 over 2, D equal 1 over 2, and we obtain precisely 0, 0, 0, minus 1 over 2, 0, 1 over 2, 0, 0, 0, 0, 1 over 2, 0, minus 1 over 2, 0, 0, 0, and yeah, that's exactly our matrix. The solver SDP of the computer is doing this extremely fastly of this optimization problem, this constraint, and maybe we just want to explain now that yeah, maybe I'll do another video about it. So we just find now the optimal we find the feasible dual point from the dual problem, and maybe we'll do a remark on the next video.